Excellent. So thank you. Sorry about that. Okay, so well, I suppose quick introductions, and then we'll get going. So I'm Steve Poole. So I'm the least hair on the left, and I work for Sonotype as a developer advocate. And primarily, what I'm focused on is helping Java developers become better from a security and supply chain point of view, and hence talking about deserialization. Markus, do you want to introduce yourself?
Sure, thank you. So my name is Markus Kett. I'm CEO, co-founder of MicroStream, and I'm worked with on Java development tools, graphical user interface builder, and database development tools for more than 15 years now with my team. So we are focused on now building serialization and persistent solutions for Java as open source.
Cool, thank you. So most of this session is going to be me, but there's a few minutes at the end because Markus has some cool stuff that is really worth showing off and talking about. So this talk is about Java deserialization, and I'm going to go through why we need it and how it works, how it gets exploited, and maybe talk a little bit about how we can defend about it. So it's a whirlwind talk because this is actually a deep subject, but I'm going to try and take you through it so you get the sense of this. As a Java developer, you will have been exposed to serialization everywhere, even though you may not realize it. And it is a topic that you have to understand how it works because you have to live in the world where it exists. So it exists from almost the beginning of Java. It wasn't actually in the very, very first go round, but very quickly after Java was created, it became obvious that if you have an object graph in a Java heap and you want to share that data with somebody else, you have to have some way of getting that object graph out of the heap into somewhere else. So if you're trying to scale and have multiple JVMs, you want to share objects. And ideally, what you want to do is take the object graph from one JVM and push it over to the other side and just take the bits that you need, but also make sure that what you get in terms of data and identity is identical, because you just want to copy the objects from one side and move them to the other. And that's been very successful. It is used all over the place. And even if you think you're not using serialization, the chances are that something that you're doing, some framework, some toolkit, some API, somewhere in there, somebody is doing something to do with serialization, and it's probably using the native serialization. You can find it by looking for this. So there is a class called object input stream, and it is the way that you read serialized objects. There's obviously a writer as well as an input as a reader, but you can go to GitHub and scan for the number of people with this, and you will hit, as you can see, enormous number of hits. Loads of people use this because it is so useful. Using it is really easy. You just have to opt in, and you add the implement serializable to your Java class, and pretty much that's it. Serialization will do all the heavy lifting for you, and all you have to do is add some code that goes with it, which is these input and output streams. So you can see here some examples. You create an output stream, wherever you're going to put it, in this case, a file output stream. You create an object output stream, and you write an object. And as long as that object is serializable, it will get written. And if you want to bring it back, you do exactly the same. And there you are. You now have an object which you've read off the string. It's that easy. If you don't opt in and you don't put is serializable on it, then when you try to write it or read it, you will get an exception. Or when you write it, I mean, you'll get an exception. So on the face of it, it's a very easy tech, and it's very useful. Take an object stream, write it to disk or whatever, and pull it back when you want. And I'm sure you can see all the benefits of being able to do that. The challenge for us is that actually there's a whole bunch of side effects, which come from how it works. So that's really what I want to talk about. So how it works. How does serialization work under the covers? Well, I need to start off by talking about some bits and bytes, but we won't do this for very long because it's just too complicated to parse. But basically, when you have an object that's simple and serializable, which in this case is the one at the top that says OC1, you have a field called hello in this case, and its value is hello. Then when you use the code in the second box to write it, you get a whole bunch of binary output. And if you start looking at this binary output, then you start parsing it. And there is a format for this. There's a well-specified format, and you can easily go find that. It's quite straightforward. And you can parse this to your own content. But why would we want to do that? Well, for this purposes, I'm going to turn it into a table so that you can see the values that are in there, because this is quickly what we're going to talk about. So there's a bunch at the stop that tells you that it's a serialization stream. There's a set that talks about it's an object or a class, all these sorts of things. So you can see some similar things like the name of the class and some flags and a field name. And there's the hello tucked down there, UTF-8 field name, hello, and a class name because it's a string. So that's cool. And then finally at the bottom, you can see the data. And, it's a pretty straightforward data stream. And the only real complexity in it is that there is a thing called serialization version ID, which is a marker that tells you that the class format that you have matches the one that's expected. Because obviously, if you're moving data from one system to the other, implicitly the classes have to be the same. You have to have the same fields and the same types. And that's what that's there for, is to make sure the system can just check those. But, mostly what we care about is the bit at the bottom and the fact that it is self-defining. So this is the bit you have to get your head around. And I'm going to go over this multiple times so that you can understand. It says here that you've got a field type L, you have a field name hello, you have a class name, you have flags. But this is not the definition of what's in the class, other than the field name. This is the definition of the data that was in that object. And so it's self-defining, and that's going to be the thing that's going to bite us, and you'll see. But ultimately, we're going, this thing is really easy. I can take this set of objects and I can create these byte streams. And because it's self-defining, I can just look at the object and go, oh, that's what I've got. And I can write it to the stream, and any objects it has and any primitives will get written and written and written. Okay. So the fact that it's self-defining, though, means that it's vulnerable, because what happens if I was to be a bad actor and I was to get this byte stream and I was to change the values in this field? So what happens if I change it from a string to a number? What happens if I say, look, there's a field called hello and it's a number, and here's the value for the number? Well, when I deserialize that, I get an error, which is exactly what you would expect. I get a class cast exception because an integer won't fit into the slot that's a string. Okay, so that's cool. So that says, are we safe? Does everything happen nicely? Are we protected because the system will prevent those sorts of bad things happening? Well, not really, because you can look at this in a different way. So let's take this code and this subtitle that we've got, the subtable. So forget all the extra bits. Let's focus on the important bits: the name of the field, what type it is, what its class is, and the fact what its value is. So I've got one that's a string. What happens if I don't have a string? What happens if I have an object? Okay. Well, actually, if you look, the only thing that changed was the class name, right? So now I have object, right? Let's use that instead. Well, now I can have data fields. I can have data in my serialization that's strings, because it could be hello, or it could be arrays with values. It could even be a hash mark. It could be any complex object. And so depending on how I've set up my Java, my class, I can have objects stored in there that maybe I wasn't expecting. So that's the first challenge is that if you are generous and you make the object type in your object, the field type, too big, like an object, then anything can turn up, and in which case you've got to deal with the fact that anything can turn up. So that's pretty bad, okay? And then when you start to understand a bit more about how serialization works, you begin to see how this starts to not be as optimal as we hoped. So more code. So here's a class called foo, and it has some static initializer, which gets run when the class gets loaded, and an object instead, a constructor, which is obviously going to happen, which is obviously when you create the object. So if I do new foo, right, what I get out is these things at the bottom. I get a message that says the static initializer has been called because it's the first time the class has been loaded, and I get object constructor called. So this is normal code, right? This is what you would normally expect if you just knew something. This is how you'd expect it to behave. So if I take my class that I had, which has this string field, and I subvert the serialization form, and I say, no, I want you to instantiate something that's called org.random.foo, you know, the class that we've just seen. What happens? Well, we've got two calls, two printouts that are coming. We have one that's the static that gets called when the class gets loaded, another one that gets called when the object gets instantiated. So when we call it, when we do this deserialization, we get the message that says the class has been loaded, and then we get a class cart exception, right? But have a look at this. We get, it says instance. So an object has been created, but we did not see any information from that message that was called, that was part of the constructor. When Java objects are instantiated via serialization, no constructors are called. And you have to understand that serialization has a different way of creating objects. So at this point, I've already explained to you that objects get created differently. So constructors don't get run. And if you think about it, that makes perfect sense because of what we're trying to do here. We're trying to take an existing graph of objects and move it from one system to the other. So in theory, we don't want constructors to run because we already have an object. We're just moving it from place to place. But the system has to actually, under the covers, create the space and populate it, which is why it has its own form of instantiation. Now, even if they're the wrong objects, they have still been instantiated. And as you'll see in a minute, instantiation may not mean that your constructor get called, but other code can get executed, even if it's simple things like static initializers, right? And even though this might all fail in the end, maybe that the object we've created won't fit in the field type and we get that class exception. When that happens, even when that happens, even though it's all failing, it can still be good for the bad guys. They don't care necessarily that it's successful. They just care about the journey and the code that gets run getting there. So look, here's another way of thinking about it, so you can get this in your head. I have another class, implements serializable, has an array as a field, has a constructor that populates that field, and there's a method that returns the size, right? So if I take this object and I serialize it, I get a nice big table, and it says, as you can see at the bottom there, 1, 2, 3, 4. It's cool, right? And then if I deserialize it, okay, and I ask it what's the size of the object, the answer is going to be 4, right? Not because the constructor got called, but because we populated the array with we filled with the array in the byte stream. So data.length data gets populated, and when we ask how big it is, it says 4. So we get what we expected. But if I was to manipulate that byte stream and say that the contents of that field is now null. So I just put null in instead, right? Constructors don't get called, so there's no instantiation of that code. So when you get down to asking it to, when you call the method and you say, what's the size? Data is null, you get null pointer exception, right? And you can imagine that could cause chaos just on its own, let alone some of the other aspects of this. Right. Now, you might think it's just those classes that implement serializable, but unfortunately, if you have a parent-child relationship, then subclasses can opt parent classes into serialization process. So just by adding implement serializable on a subclass, then that parent class becomes part of the process. And if you have interfaces, where you have interfaces, in this case, like IFU, you have a public class that implements it, you may be the person creating foo impl. You may believe at this stage that you're not part of a serialization stream, so you don't have to put any protection in. All it takes is somebody to do something stupid and change the interface to extend serializable, which has happened, and now suddenly your class, your embodiment, is now serializable. It can be as simple as that. Java serialization is this great gift because it's self-defining, and because we don't consider as developers that we might get data we're not expecting, and we're relying on the system to protect us. It becomes a great way for developers, of the bad guys, to hack into our systems. And much as you may go, well, I'm never going to use Java serialization in my application, unfortunately, 90% of modern applications are open source, i.e. you didn't write it. And believe me, you go searching for code results using implement serializable, and you will hit millions because it is around, because it's been in Java since the beginning, and it is super valuable to everybody. So how is it to exploit this? You know, what you saw was a really simple way of just hacking it to break your system, maybe change the data. There are these other things that are the prized tool of the bad actors, and they're called gadget chains. And effectively, and here's a representation, the idea is that because you can put arbitrary objects in places, or semi-arbitrary objects, and methods get called and codes get run, objects get instantiated, that you can construct complex chains from some start, in this case, at object input stream.read object at the top, all the way through to doing something which the bad guys really want to do, which is the runtime exec at the bottom. That's what they're trying to get to. Now, this may look really complicated, and you may go, oh, this is too hard. Nobody's going to do this. You know, is it really hard to do this? Well, unfortunately, there are tools out there, this is just one of them, that will very nicely exploit the vulnerabilities in your system and build gadget chains for proof of concept by both, unfortunately, the hackers, the bad guys, and those people who penetrate and test this. And these tools are very good at being able to exploit the vulnerabilities in versions of code that you've got. You have a vulnerable dependency on your class path. There are tools out there that can make use of that and hack your system via serialization. And as we know from Log4Shell, this has been a big problem because even now, so this is downloads from Maven Central, Sonatype run Maven Central for the community, and here you can see the horrific numbers that even now, where we're talking almost a year since Log4Shell hit the streets, 33% of downloads for Log4j binaries, dependencies, are vulnerable versions. So we're not very good at protecting ourselves from this, and Log4Shell is just the sort of the canonical example of how you can use serialization to get into a system. So that's the bad news. What can we do to defend ourselves against this? What can you do to prevent it? Well, there are some active things you can do. They're all under the idea of taking control. So the very first thing you can do is look at your own object input streams. There's information on the web, and here's an example that's been around since 2013 that says, here's how you can build object input streams that do not have the weaknesses we've just described, but unfortunately it only works for the object input streams that you have control of. And unfortunately, there are many, many others out there. So it's good for you to look at whether you can use it for your own protection, but it doesn't give you the panacea you're looking for. If you want to go deeper, then you start having to write code. Unfortunately, this is complicated, but effectively there is a method in there you can see. It's called read object, private void read object, object input stream in, throws, etc., etc. You have to get that signature exact, because if you don't, it won't get called. But if you do this, you can see it's a private method. You have to put it on every single class that you care about. And if you have the object hierarchy, you have to put it on every single class. But this means that this method will get called during object input, and you can then decide what you want to do. So you become part of the process. But if you spell that wrong, you get the signature wrong, then it will not get called, and you will never know unless you're tracking it. So there are lots of things you can do here, and the most obvious one is to add something like this, which is effectively you just opt out. So you can put this method on every class that you do not want to be part of the deserialization process, and do something like this. And then every time somebody tries to deserialize your object, you'll get an IO exception. But again, you have to do all the heavy lifting. There's no easy ways for you to do that. Now, there are tools within the SDK, within the JDK, to help you limit the risk. There are things like properties that you can set that tell you whitelisting and blacklisting, the ability to say things like what the size of an array might be, so you can prevent denial of service attacks, but it's all very crude. Java 17 added more stuff, which makes it easier, but it is all very much about you understanding what you're allowing in and what you're going to prevent, and it's all whitelists and blacklists. It is complicated, and it doesn't deal with any of the modern types of attack that you might see, which are called dependency confusion and typo squatting. I'll let you look those ones up. So there are other things you can do, and one of them is just remove the available code. And so if you can use modularity, then use modularity, because Java modularity has limited class paths. So there's no code in the class path, the bad guys can't exploit it. Well, I say that, but actually, as Log4Shell showed us, there are still windows. The JNDI attack that was part of Log4Shell exploits an older capability, which is in theory shut off on modern JVMs, which allows the serialization form to include classes that do not exist on your class path, just totally remote arbitrary code that can be pulled in. And that's, again, you don't want that to happen, and you definitely need to lock that down. Modularity will help you, but also using latest JDKs will give you more benefits. So that's sort of what you've got in the JDK. There are other things that you can do, but this takes you now into the idea of just designing differently. So the first thing you can do is say, I'm not going to share, use Java serialization at all, or maybe in this case, what I'll do is I'll do it slightly differently. So one of the common weaknesses that we've seen with people who use serialization is that they take the object tree that they've got that's for their application and they try and move it across. One simpler defense is to create a small subset of objects that represent data in very primitive terms. So it becomes very hard for the bad guys to exploit it, and they're certainly not getting into your application objects where they could do possibly more damage. So the idea is you just create very simple Java objects that represent some data stream that you want to define, and you send that over and receive it. Of course, you've got to put the heavy lifting into creating and sending and receiving that, but it does make it a little bit easier and a little less fraught. And if you've got Java 14 onwards, you've got records, and you can do that again, just slightly easier. You can create Java objects that just have the data you want in, don't have code, and are as limited as you can make them. Well, there are still other things we could do. And one of those options is to talk about not using native serialization at all. There are other forms of serialization that you can use in the Java space. You can use XML, you can use JSON. There are tools out there that can allow you to take objects from one system to the other in a different form. Now that does help, because then the form of the data becomes very simplistic, because now we're talking about just really basic data forms, pairs and lists and arrays. But just as a warning, if you do look at using some of these other formats, you should take care, because some of the tooling out there actually allows you to specify the names of the classes to be used when you deserialize. So that brings back some of the existing weaknesses. But if you don't do that and you just use these data directly, then there you are. There's another way of doing it. But you have to create all of the objects that create and that create these object trees or these data forms and bring them back. You have to write all that. It's not provided for free. Well, luckily though, we have one more, which is a way of doing this. There are other tools. So I'm going to hand over to Markus, because he's going to take us through another way that maybe this will help you reduce your serialization impact by just using a completely different approach.
Thank you very much. Great presentation, Steve.
Can you take control, or do I have to give it back to you?
Yes, it's possible. It's insane. So yes, I guess this is the reason why Mark Reinhold also, as the chief of the Java platform, said that Java serialization was a horrible mistake, and there are also talks online on YouTube of Brian Gertz, where he explains, there's one talk, it's called Why We Hate Java Serialization.
Yes.
And they explain also the vulnerabilities, and yeah, it's really incredible. Yeah, he said also that Java serialization makes every mistake, nearly every mistake imaginable. Yeah, and he also has a huge blog where he explains the serialization vulnerabilities in detail. The core thing is, the core problem is that Java serialization executes code automatically through deserialization, and with MicroStream we build the persistence layer, and the concept is to store Java objects by using serialization. So the question now was, can we use Java serialization for that? Because it's that insecure, and by the way, it's not that fast, and it has limitations. So we were not sure. So actually, for us, this was not the way to go. We had various limitations with Java serialization. Yeah, you have to implement the interface serializable. We cannot serialize all types. We cannot serialize types from third-party APIs. And also Java serialization has problems with more complex object graphs. So the depth of your object graph is limited. And this is the reason why we decided for MicroStream to write serialization completely from scratch. And this is the reason why MicroStream uses a new serialization, and we had to do it from scratch, and we had to do it completely fundamentally different, and not to become a drop-in replacement. This is also described by Brian Goetz, and he said all the other serialization are trying to be a drop-in replacement, and so they introduce the same vulnerabilities, or they focus on the format using, for instance, JSON serialization. Steve, you mentioned that, but then we have this. This leads to another limitations, like it's not possible to serialize more complex object graphs with circular references. So this is not possible. And so this was the reason why we did it fundamentally different. And now with MicroStream, you can serialize all types, all Java types. You can serialize classes from or objects from third-party API, and through deserialization, no code is executed. So this is the main point. So we strictly separate data from code. We only transfer the data, and no code is executed through deserialization. And the objects are generated by the framework. So injecting malicious code and trying to execute malicious code is impossible. The requirements are very low, so you can use plain Java objects. So you can see here a class, so there's nothing specific. There are no annotations. There's no interface to implement, so you can just use it and serialize it. And right now, from the NCC group, just in time, we received a report. They proved MicroStream for many months. So 8 months ago, so when we started the project together with NCC group, and now we have received the final report, and here's the conclusion. They also say that Java serialization is the biggest security flaw in Java, and with MicroStream, this works fundamentally different, and it strictly separates data from code. Transfers data only, and so injecting malicious code is impossible. And so MicroStream provides one of the most security serialization on the market. So if you don't want to be hacked, yeah, you can check it out. MicroStream is now also part of Project Helidon, so it's integrated. It's well integrated with Helidon. And also it's well integrated. We have a really great integration with Micronaut. So if you use Micronaut or Helidon, you have MicroStream out of the box. And with MicroStream, you also get the persistence layer. So it's, yeah, you can use the persistence layer, or you can use the serialization standalone. So that's on you. It's simple to download it via Maven. The code is on GitHub, so you can check it out. It's under EPL license, so you can also use it for commercial purpose, of course. Yeah, and use it to high secure your products. There are also some other interesting use cases, perhaps, and this idea was introduced by Adam Bean. use MicroStream to store objects seamlessly in Kafka or other event streaming platforms like Pulsar or so, then with MicroStream it's really convenient because you can serialize all of your objects, all types. You don't have to implement any interface, and so it's super easy. There's no JSON conversion, and it's super easy to store data in Kafka or to store objects in Kafka and to get the objects out of Kafka just by using MicroStream. So this is very convenient, no more conversion behind the scenes. And yeah, it's a use case. Check it out. Perhaps it's useful for you. Then another use case is using MicroStream together with AWS Lambda or other serverless functions on other platforms. Here with the serverless Lambdas, we have the challenge that they are actually stateless, or if they have a state, for instance, you have data in a Lambda and the Lambda goes down, then your data is lost. So this is the reason why your Lambdas should not have a state. You can solve this, or a common approach to solve is just persist the state of the Lambda and today it's done by using JSON serialization. And so you can serialize your objects and store it in DynamoDB, for instance, or you can use AWS S3, which is cheaper, the cheapest way, for instance, and the obvious way to go because it's a blob storage. But here again, there are trade-offs if you use JSON serialization, because you cannot serialize complex objects, no circular references, and so this is not possible. And you have a latency of the serialization. JSON serialization, by the way, is fast. It depends on the complexity of your objects, which approach is faster, JSON or MicroStream. The more complex your objects become, the more the faster MicroStream is in comparison. If you serialize simple flat objects, then perhaps JSON will be even faster. But with MicroStream now you can serialize and persist the system, the hot system state of your Lambdas, and then they can shut down, and you can invoke the Lambda anytime and can reload the system state from the file storage. It's just by calling get and set methods. So this is really convenient. No more conversion behind the scenes. It's super object oriented, and it's no dirty hack, and it's secure. So this was a second use case, and with MicroStream, you not only get the serialization. This is the core of MicroStream. On top of this, we have a persistence layer built for the JVM. We have the same persistence layer that runs on Android, and on top of the serialization, which is also very interesting, we deliver a so-called legacy type mapping, and this manages your class changes. So always when you change your classes, then it might be a problem with serialization. With MicroStream, you have this legacy type mapping, and MicroStream cares for the type mapping through runtime. So this is super convenient. Then we added the file system garbage collector. It's because of the persistence layer. So if you persist data with objects with MicroStream, then the binaries are stored, appended to the file storage. And if you change your classes, then it costs to legacy objects in your storage, and the storage grows more and more. And with this file system garbage collector that runs in its own thread and removes the legacy objects from your storage to keep the storage small. And we have a file storage, a file system abstraction that you can run the serializer everywhere, and the persistence can be also anywhere. So, for instance, you run it inside a container and your file storage is outside. So this is also possible. And even we have database connectors. So I mentioned already AWS S3, but there are also additional connectors to all important database systems, REST interface, and also file storage garbage collector. So this complete package is provided by MicroStream. And it's completely open source under EPL license, so you can check it out, try to hack it, try to exploit it, and if it works for you, you can use it for free and secure your applications. So now we have time for questions.
Yeah, I think so. So what do we have? Is the MicroStream serialization safety proof of concept available somewhere? So I think, Marcus, how do people get, so when I did a whirlwind through serialization, we didn't touch on any of the really sharp edges, and we know that people consider this to be, you know, like Brian and others have all shaking their head in shame and going, we should never have done this in the first place. So we need people to move off it, and MicroStream seems to have all the right characteristics. What do people do? How do you have something that says don't use serialization, use MicroStream and here's how to?
Sorry, I was not able to understand that.
Do you, so what do we have in terms of getting started for MicroStream? So if we've got Java developers out there who are looking at having to, they've decided to consider maybe using serialization for something, what do you have some getting started guides that they could go read now that they could use instead of dropping into Java serialization?
Yes, on the MicroStream website, you can find the documentation. So I think it's well documented and should be really easy to start. Keep in mind that MicroStream is not a drop-in replacement. Migrating is simple, but it is not a drop-in replacement. And the reason is, as Brian Goetz wrote in his article, in his blog, if it would be a drop-in replacement, then we had to repeat all these mistakes again. And so this is the reason why there is a migration path, but it's simple.
Yeah, and I just want to reiterate that. You may look at something like MicroStream or anything else you use, and you may go, I've got to put effort into it. But honestly, we need people to be putting effort into different ways of doing this because of the vulnerabilities that are inherent in serialization. Maybe things will get fixed, but later on. But if they get fixed, they'll get fixed by cutting away a lot of the capabilities within serialization. So you could easily find yourself broken because the fact that you're exploiting those capabilities. So you really need to start looking at MicroStream and others as ways of doing this. And my advice would be, if you're starting to go down this road, then start building some classes that you can use as a front end to this and try out the different mechanisms. Yeah, thank you. So I'm not quite sure how much time we got left. 3 minutes, maybe? So I get the takeaway that people would like to see some actual code in action. So Marcus, you and I, maybe we should talk that through and see what we can do to come back at some point or go somewhere else and actually do some sort of mini workshop so people can actually kick the tires on this.
We have a workshop on sorry for interrupting.
Yeah.
We have a workshop on Friday. You can enroll for free, and there we can show how pure serialization works. And there are also some other sessions about MicroStream, and we have videos online. But if you have some time on Friday, check out this MicroStream workshop, 3 hours, and we explain the basics and how to get started. It's really, really simple. The learning curve is really flat.
Cool, thank you. And I say, even if you're not thinking about MicroStream as a candidate, going to one of those workshops will also teach you a lot about the base Java serialization, and that's a good learning exercise too.